So lesson 4 is about solving trig equations. We did a little bit of this on your quiz on, I think it was Thursday that I last saw you. We're using the same ideas of just solving for x in any equation in order to solve trig equations. And the way that we're going to do that is by substitution, essentially. Okay, so in grade 11, we learned, and grade 10 probably too, you learned how to factor a quadratic to solve for x. So if you have a quadratic function and it equals 0, we look at the first number and the last number. We're looking for two numbers that will multiply. 2 times -1 is -2. And we'll add to the middle number, which is -1. What are my options? Multiply to -2, add to -1. -2, +1. Now, before I use these as my factors, I have to check if I have a leading coefficient. I do. The leading coefficient is 2, so that means I have to divide my two answers by 2. This gives me -1, and this gives me 1/2. So this equation can be factored. X minus 1, 2x plus 1. Or you could also factor it this way, x minus 1, x plus 1/2. That's okay too. Either way is fine. Okay, so because this equation equals 0, this tells me that my solutions are x must be 1 or x must be -1/2. These two values will solve the equation. We're going to do exactly the same thing, but with trig. So take a look at example 1. Sorry, did I scroll too fast? In example 1, we have exactly the same equation, but instead of an x squared and an x, I have a sine squared x and a sine. The way that I solve this is going to be the same, right? In factored form, this is going to give me sine x minus 1 times sine x plus 1/2. Because all I have done here is replaced the x with sine x. It's still a quadratic equation, something squared plus something plus a constant. So the way that I solve a quadratic is going to be using the same steps. That means my two solutions are sine x equals 1 or sine x equals -1/2. However, in this case, because I made a substitution for sine x, this is not my final answer. This is telling me the sine of x, and I'm interested in just x. So we have to use our knowledge of the unit circle and our special triangles. On the unit circle, I write CAST. This is where cosine, all, sine, and tangent are positive. I know that the coordinates here are 1, 0, 0, 1, -1, 0, and 0, -1. And that the x and y coordinates represent cosine theta, sine theta. Okay, so these are the things that I should just know about trig. This is the things we learned about in our previous lessons. I also have two special triangles to refer to. 1, 1, √2. And because we are working with radians pretty much from now on, this is the angle pi/4, and it's the same angle because it's an isosceles triangle. And my other, oh, you know what? I should move this over because where I put the, I'm just going to move it up here. My other triangle is this one where I have 1, 2 root 3. My bigger side is pi by 3. My smaller side is pi by 6. Okay. So using these three images, which one will help me solve sine x equals 1? The unit circle or a triangle? Unit circle, right? Because it's not a fraction, it's a point. So where on the unit circle is sine x, meaning the y value, where is the y value 1? Top of the circle, 90 degrees, or if I were to do this in radians, sine x is 1 when x represents how many radians? What's the top of the circle represent? Pi over 2. So that is my final answer. Okay. Now for the next one, I have sine x equals 1 over 2. And don't forget that it is a negative 1 over 2. So my y value on the unit circle is 1 over 2, and it's negative. Well, there's two possibilities. Either I am somewhere over here or I am somewhere over here. Both of those legs have a negative y value, right? Now, using the triangles, which triangle gives me an opposite side of 1 and a hypotenuse side of 2? Will be this triangle, right? And if this is opposite and this is hypotenuse, then this is the angle I need. It's pi by 6. What this tells me is my reference angle is pi by 6. So I look at the unit circle and I say, okay, if this little piece and this little piece are both pi by 6, what is that angle in standard position? X equals what? How many pi by 6s? Okay, how many pi by 6s is half the circle? 6 over 6, so that's 6 pieces. And I'm going another pi by 6 over, so how many pieces do I need? I need 7 pi by 6s, right? Okay, what about this other one here? If I go all the way around and what's left over is pi by 6, how many pi by 6s do I need to get to the other side, to the other arm, I mean? How many pi by 6s is the entire circle? 12. So if I have one less, 11. Okay, this was your quiz on Thursday, right? What we're adding now is one extra step. We got to solve for sine x or cos x or tan x. And then we're still using our reference angles to find what are the possibilities of the actual angle. Yes, ma'am.
Why are we doing a full rotation before defining our x? Like, why is it 7 pi over x? Like, we have to do a full rotation.
It's not a full rotation though, because remember a unit circle, this top half goes from 0 to pi, or 6 pi by 6. A full rotation all the way around is 2 pi, or 12 pi by 6. So to get to this angle, I need 6 pi by 6 plus 1 more, so 7. And then same going all the way. All the way is 12 pi, minus 1 is 11 pi by 6. Okay, can we give a nod or a shake of the head if we're like understand the concept? Okay, so all the questions from today's homework are kind of like this. The equations are going to be looking slightly different, but how we solve them, this is how we do it, okay? So let's take a look at example 2. I want a factored equation that equals 0. Okay, so I want it to look like this. Factored and equal to 0. What would my first step be here? Move it over to the other side. Good. So I'm going to minus sine x from both sides. Tan x times sine x minus sine x equals 0. So it equals 0. That's good, but I want it in factored form. What's my next thing? Factor out sine x. Sine x, bracket, what's left over? Tan x minus 1. Perfect. Equals 0. Now it's in factored form. So using the rules of polynomials, either this is 0 or this is 0. So sine x equals 0 or tan x minus 1 equals 0. Okay, let's start with the sine x. Where on the unit circle is the y value 0? At 0 or, say again? 180 degrees. Okay, again, in radians. Pi, yes. So either at 0 or at pi is the y value 0. Those are my two possibilities. Okay, so let's take a look at tan x minus 1. That's not a finished product there. That's not a finished equation. I remember I want to isolate x. What could I do here? I want x by itself. I can move the 1. Tan x equals 1. Okay, two ways to think about this. Either I'm going to say this is opposite over adjacent, and they have to be the same. Or you can say this is sine over cosine, but again, they have to be the same. Okay, so opposite and adjacent have to be the same. Which triangle has an opposite and adjacent side that are the same? What's my reference angle? Pi by 4. Okay, so pi by 4 is my reference angle. Now, where on the circle is tangent positive? 1 and 3. So again, pi by 4 is my reference angle, so it's the angle between the arm and the x-axis. So it's this part here and this part here. So my options are this angle or that angle. So what's my solution? X equals. What would make that true? Pi by 4 and 5 pi by 4. Right? Because the halfway point is 4 pi by 4. If I'm going one more forward, that's 5 pi by 4. Okay, so here now is my final solution. What makes this true? It is true when x is 0. Pi by 4, or 5 pi by 4. There are 4 possibilities that make this true. All right, so we're always going to be using reference angle, the unit circle, things we know that are true, right? Tangent is sine over cosine. If that's not helpful, tangent is opposite over adjacent. Take a look at your triangles. And then we use the idea of coterminal angles to find the general solution. When we're looking at sine and cosine, the general solution is just saying that whatever angles you find that work for your equation, if you walk around the circle 360 degrees and you end up in the same spot, that is also a solution. So you can walk forwards around the circle or backwards around the circle. If you end up in the same spot, then that is a solution. So the way that we write that is whatever our answer is plus 2 pi n, where n is an integer. Who remembers the definition of an integer? No fractions, no decimals. What else? Could be negative or positive. So negative or positive whole numbers in 0. So plus or minus 0, plus or minus 1, plus or minus 2, etc. No decimals or fractions. So you can walk around the circle forwards or backwards as long as you end up on the same spot. That is a solution. So let's take a look at what did we get from example 1 and 2. And you don't have to flip your page. I'll flip it for you. In example 1, we got that x equaled pi by 2 or 7 pi by 6 or 11 pi by 6. So my general solution plus 2 pi n. If I am at 7 pi by 6 and I add 2 pi, what's that going to give me? 7 plus 12 is 19. 19 pi by 6. That is a solution. Or I could go backwards. You could go around the circle 5 times if you want. Add 5 times 2 pi. You'll end up back at the same point. Okay? So general solution, we add 2 pi n. I am going to make a small exception, not exception, but an interesting note. When we are solving for tangent, look at where tangent is positive. Let's say my pi by 4 example from example 2. Tangent solutions are always separated by 180 degrees, or they're separated by pi. So tan general solutions are usually referred to as x, whatever your number is, plus pi n, because they're separated by 180 degrees. If you forget this, that's fine. It's just an interesting fact about tan. It does come in handy later on, but if you just use the 2 pi n, that is also correct. Okay. Okay. Let's take a look at a more complex example. Here I have sine 2x equals root 3 over 2. Now I have a question where inside of the sign I have something I don't recognize, right? Because, excuse me, we have only been dealing with trig of one thing, such as theta, root 3 over 2. This is a question we can definitely do, and we can do it well. So what I'm going to do is, again, substitution. I'm going to let theta represent 2x, just for now. If I can find the solutions for theta, I'm going to use that to then solve for x down the road. So I use substitution. All right, so sine theta is root 3 over 2. Either you can think of this as opposite, over hypotenuse, or you can think of it as a point on the graph. Where on the graph is sine positive? Which quadrants? 2 and 1. Okay, I'm looking for a reference angle, so a triangle. that has an opposite side of root 3 and a hypotenuse of 2. What angle am I needing? Pi over 3. Okay, so my reference angle is pi by 3. What are the actual angles that would get me there? So from standard position to the first arm, from standard position to the second arm, what are my two angles? Two pi by 3 is one of them. Yeah. That's this one. What's this one? Pi by 3. So my options are pi by 3 or 2 pi by 3. And if I were to write this in general solution, plus 2 pi n times, where n can be any number, positive or negative. But I'm not done. This is the final solution for theta. We want the final solution for x. So let's go back to my substitution equation. If I wanted to write this as x equals something, how would I rearrange this equation? X equals what? Almost. Theta over 2. Say it louder. Be more confident. Yes, theta over 2. Right? Theta is 2 times x. Therefore, x is theta over 2. So in order for me to change this into an x equals solution, what I have to do is divide everything by 2. Okay, talk to a partner. What's my solution for x? Pi plus pi, and there will be an n. You tell me what the numbers are. Pi by 3 divided by 2, what's my new fraction? Pardon? That would be multiplying it by 2. Pi over 3 would now become pi by 6. That's an ugly 6. Let me try again. There we go. Pi by 3 becomes pi by 6. 2 pi by 3 divided by 2 becomes just pi by 3. 2 pi n divided by 2 is just pi n. Okay, we're done. There it is. Okay, if you're not sure how I got from here to here, do it this way. Pi by 3 divided by 2. Pi by 3 times 1 over 2. Tops together, bottoms together. Okay. Yes?
Are we doing plus minus 2 pi n or just plus?
Just plus because n could be negative.
Okay.
So we don't need to do the plus minus, but that's a good question. Yes. Okay. Are we happy with this? All right. The last example is basically the same thing, but it's a calculator question. Okay. So we have to be okay with the fact that not every trig equation is going to use our special triangles. When the special triangles don't work, we have to use our special brains and special calculators. But essentially the steps are the same. Okay, so I begin with this equation. 7 cos theta plus 5 equals 2 minus 3 cos theta. It's asking us for a solution between 0 and 360. And notice that this question is in degrees. So when I work with my calculator, I got to make sure that my calculator is in degrees. 0 and 360 means I'm only looking for a solution in one rotation. Okay? I'm looking to solve for theta. I'm interested in suggestions. How and where would you start? Okay, how would I do that?
So you would add 3 on both sides.
Add 3 cos to both sides. And then subtract 5 from both sides, okay? So 3 and 7 coses make 10 cos thetas. This goes away. 2 minus 5 gives me -3. This goes away. Okay. Next step. Divide by 10. Okay, so this represents adjacent over hypotenuse. We do not have a special triangle that has a 3 and a 10 in it. So right away, this is a calculator question. However, this is telling us that cos is negative. Where is cos negative? Quarter 2, oopsie, and 3, yes. Here and here. So we are looking for this reference angle so that we can determine what is this angle and what is that angle. Okay, this is now a grade 10 question. How do I get theta by itself? What do I need? Inverse cos, yeah. So theta equals cosine inverse of -3/10. This is now a calculator question. I'm going to click on mode and make sure that my calculator is in degrees. It is usually the third option on these TI-83s here. All right, so I'm in degrees now. Cosine is 2 buttons above the 8. However, I need inverse cosine, so I have to do second function and then cosine. So inverse cosine, and I'm using -3, not -3. We talked about the difference between negative signs and minus signs before. And I hit enter, and it tells me that the degrees is 107.5. I'm just going to round it off here. So this is my reference angle, 107.5. Okay. On the unit circle, this pink angle is 107.5. How would I find what is this standard position from the beginning? What could I do? 180 minus 107.5. So my first solution is what's the number? I did something wrong. Hold on. What are you getting for your first angle? 72? 72 degrees is not in the second quadrant though. Hold on, let me just double check. Oh, I'm sorry. Sorry. I caught my mistake. This is telling us one of these solutions, that our angle in standard position is 105 degrees. And I'm going to do a little squiggle because I had to round it. It's not exactly 107.5. Apologies. My reference angle, the reason I need my reference angle is because I know that there is a second solution. Okay, I'm going to erase this little diagram and redraw it. I know my solution is in quadrant 2 and quadrant 3. My calculator gave me the first one, 107, in this position. However, I know that there is another possibility for it to be right here. Now, this is 107.5, and two ways you can do it. Find what the reference angle is, and then add it to 180, or take 360 and minus 107.5. So either way that you do it is fine. Pick the way that makes sense to you. Okay, so our calculator gives us our first solution. Our diagram helps us find our second solution. So our second solution will be 360 minus 107.5, or you can say 180 minus 107.5 equals, I think we get 72.5. And then we add it to 180, and this will still give us the same answer, which is 252.5. Okay, so solution 1, solution 2. My final answer is theta equals 107.5, or, oh man, 252.5, and this is between 0 and 360 degrees. I'm specifying that this solution is only works in the first rotation. The general solution would be 107.5, 252.5 plus 2 pi n. Actually, technically, since we're in degrees, this would be 360 n. But you understand my point there. Okay, sorry for my little mistake there. But that is the end of lesson 4. Okay, so on your homework, hold on before you run away with me. On your homework, there will be a couple of questions that are calculator questions. There will be a couple of questions that require substitution, and a couple of questions that are just straightforward, solve it. Okay, I'm going to give you lots of class time next time. I'm going to give you a break for now, and then we're going to move on to our next lesson, okay?